Welcome to qnawire.
Okay, this question starts with the equation for H2 and I2 reacting to form HI, and this is equilibrium here. It tells us to look at these figures that describe the timing of the reaction, going 1 to 2, down to 6 here. And it says, examine the figures, sequential in time, and answer these questions. The first question, A, says, which figure represents the point at which equilibrium is reached? And equilibrium would be reached when there's no change in the number of reactants and products. So once you have a steady state of reactants, then you can tell that the reaction has reached equilibrium. So I'm just going to loosely look at these small small white spheres, probably symbolizing H2. It's much smaller. If we go here, we have, I don't know, 9, 10 or so, less than 10. Now we have about 5. Here we have 4. Here we have 3. And here we have 3. So we went down from 10 to 4 to 3, but then we had no further decrease between panel 5 and panel 6. And then we could do something similar for these other spheres. We have 4, 8, 10 again. 1, 2, 3, 4. Down here, 1, 2, 3, 1, 2, 3. So again, the number of the blue spheres or iodines decrease, but then from 5 to 6, there's no change. So if at 5, we're reaching a level that doesn't continue to change in 6, that means 5 must be the equilibrium point. So there's no longer a change in the number of reactant molecules. Once we get to 5, therefore it symbolizes when equilibrium has been reached. B says, how would this series of figures change in the presence of a catalyst? Catalysts don't change equilibrium, they change the kinetics of the reaction, or the rate. So if you added a catalyst, it would change how fast there was a decrease in the reactants and how fast there was an increase in the products. The only thing that would change, not the numbers once you reached equilibrium, just how long it takes to decrease the reactants to their steady state levels or the equilibrium levels, and to increase the products to their equilibrium levels. So it would just be, I'm just going to write faster. And in C, it asks, would there be different amounts of reactants and products in the final figure in the presence of a catalyst? Again, like I said, in B, catalysts only change the rate, so how fast we get to equilibrium. They don't change what equilibrium looks like. Generally, the answer here is no. When you add a catalyst, you're not changing how many reactant product molecules there are, you're changing how long it takes to get to the final steady state equilibrium number of reactant products.